Hey everyone, CNC Keith here with yet again another CNC DIY video. In this video, I've stopped by MecTechMike's shop here in beautiful Annapolis, Maryland. Hey Mike, how's it going today? What do you got going on here? You know, I've been following you on the forum and I've been seeing you posting photos of this PM727. And boy, when I walked in your shop here, this is a heavily modified PM727. This is not your average unit. Tell us what you've done here. This looks really impressive.
Yeah, well, you know, I wanted to get into the business here. We're kind of making some fins for windsurfings and stand-up paddle boards. This is the latest result coming from this machine. And didn't know anything about machining really. I started really raw, just a manual machine. I was kind of using it to make molds for the surfboard fins. This was all just done manually. This part, which went to a bandsaw, was done with a boring bar. And so when I met Keith here and discovered this Acorn product coming out, I said, hey, look, I really want to get into the CNC because I ultimately want to get doing some really complex shapes with the fins. So I say, hey, look, how about I take this mill and I make it a full CNC. And so basically, as you've seen a lot of people do on the forums, and they've been a great help, especially on the Centroid Acorn forum. The guys are really, really helpful. Ended up ripping out the Acme screws, replace them with some ball screws. I kind of wanted some precision here. I went with C7 ball screws. I bought them through Misumi, because they were the only company that I knew actually had ball screws of a small enough profile. I'll show it to you here. I'm going to turn this on. I designed this ball screw in such a way that I can really pull this table aside to do any kind of maintenance. This is basically just a liner for fishing ponds that I had extra lying around. And there is the actual mount for the screw. The key was to get a ball screw that was low profile enough that could slide all the way in on the table. The Misumi was the only brand that I found actually had that low profile. So I went with them. They're a little bit more expensive than, say, your eBay generic Chinese-made stuff, but super good accuracy on this stuff.
My gosh, Mike, that's a lot of travel. What do you got on this machine here?
So yeah, I wanted to make sure I got the biggest envelope. Again, because ultimately my goal is to make these fins. These are the kinds of size of stock material that we want to be doing with. This is roughly 11 by 11. I want to be able to bolt it down and be able to mill the parts. So this is actually the table that I'm using now to do this mill. You can see one of the mistakes when I cut it out. But this now mounts to this table. I got some nice line-up holes and pins, dowel pins to lock it down. I can bolt the material through this, and that turned out really nice. And this plate was made with CNC, did nice passes back and forth, got a really nice smooth surface, used the rigid tapping feature, which really floored me. It made it so much easier just to walk through this and line up all these holes. I'll probably actually add even more holes later on when I want to do different pieces, size pieces. So I can put that on in place of the vise and the rotary table whenever I need to. So yeah, I built this all out. To get the extra travel, I also added this extension block to the head here. That kind of pushed it out a bit. Had to do some modifications. There's a video I shot on the modifications that shows what I did to cut out and make some more extra travel. So my work envelope now is 23 by 10 by 19, which is good enough for what I needed to do.
Yeah, that's pretty amazing. And that size of machine to have that work envelope on a benchtop machine.
Mm-hmm. And I've been machining a lot of parts. Part of my kids' high school robotics program. Been doing some parts. I can drop in some bearings into some bearing holes in some parts. Been able to hold down to do tenths of a thousandths if I'm careful and take time. And those bearings pop in really nicely and stay locked. So I'm really happy about that. I was able to get the precision out of this machine. So, and of course, it's all due to the controller on the Acorn here. There's the cabinet. That's the main controller. I put the spindle control separate because that has a lot of EMI, and I want to just keep that in its own cage. So basically 2 power supplies using Technic motors. One I dedicate to the Z-axis since that's the beefy boy and he's got to do a lot of lifting. He is counterbalanced. I basically used some cabling from an exercise piece of equipment. Found these on eBay, real cheap, got shipped to me. Basically got some cheap linear rails. And so this whole head is basically counterweighted to make this motor drive a whole lot easier. I can show you for Z, pretty good. I can get 100 inches per minute going on it because I've reduced the stress on that motor. And also to the accuracy, it doesn't bind because of the waist has been offset. So
give us another demo on that and run it up and down so everybody can see the action of your counterbalance. This is pretty ingenious, low dollar solution to counterbalance the column on a benchtop bed mill. Man, that's fabulous, Mike.
Yeah, I didn't want to go with any kind of gas struts or springs. They're bulky, they get in the way, and their tension is proportional to where they're located on the Z-axis. This gives a nice, smooth, consistent weighting factor on this thing, and it definitely shows in the execution of the parts. You just don't see a whole lot of jerkiness in the Z-axis because of that. So, and I can take this almost all the way to the table. I designed it to bring it down as low as I can so that if I really want the accuracy, I can take all this away and go straight to a collet and have the bit only about an inch above this, and I can get it all the way down to the table. Normally, I use this quick change. I know a lot of people like the ATCs, but I found this quick change to be very useful. There's a site in the UK that sells these things. Normally these are Royale quick change, easy change. They're super expensive as the Royale brand, but there's one site in the UK sells these at a pretty discount, significant discount, less than half the price of a Royale. And I managed to collect them, and these are just so nice because you can just pop in a set of tools. So whenever I got to do a complicated part with a set of milling bits and drill bit operations, I can literally line up these tools in a low. I can run my program, and then the program says next tool. I just literally pop in the next tool, and I can go up to the next operation. So I've been able to do near production type operations when I need to.
Show us a closer look at that, or how this actually works. That's pretty slick.
Yeah, this is an easy change. It's it's designed to fit into an R8 collet, and what I really like about it is it only takes up an extra inch in the overall thing. I mean, you can't even get a drill chuck that size, and very useful. It's good for I think up to 10,000 RPMs, which is more than I need for this. And it has a locking mechanism. It's basically ball bearings that grip there. You can load it like literally
one-handed. Yeah.
Yep. And they have different sizes. I got super chucks. I got a regular chuck. You have ER16. I have a couple of those with ER16 collets. And then I have some straight ones, like this is a 1/2 inch because that's my workhorse to be grinding out large amounts of stuff. So
fantastic. You mentioned you did the rigid tapping here on your subplate. What'd you have to do to get rigid tapping working? I'm looking at an encoder. It looks like you added an encoder up here. Tell us how you did that.
Yeah. So getting an encoder on a mill head like this was a bit of a challenge because you do need to play with the drawbar, and so you need clearance for that. So what I did is got this encoder off of eBay, managed to get the belts and the heads from I think I actually got them from Misumi again, and so I carefully mounted a cap on top of the spindle. It took some careful drilling to get that in there, but once I got that in there, I belt them off just to the side here. And so it's a 1-to-1 as required to do that. The nice thing about it is it doesn't care really what the motor spin, what the commanded spindle is. When I want to do rigid tapping, I just take this thing to low gear where I have a lot of torque power, and I take it way down low. And so I can do these holes at really low speed, a lot of torque. CNC software doesn't care. It just says it knows what the speed is and what the spindle is to know how to feed it. So it didn't take me long. It literally took me an afternoon from never doing any kind of rigid tapping, doing some soft materials and advice to just get the process straight. Once I did that, I literally popped this in here, and through intercon, I actually pulled it up through intercon, laid out the array of holes, drilled them, then I went back in and tapped every one of them. I was done in an afternoon. So that was really impressive. I really had no problems whatsoever running that rigid tapping. Basically, I used the intercon to do this operation. It was actually pretty simple. One of the intercon operations that you can do is to simply say, I want an array of holes. You tell it where to start, what the spacing is. In this case, it was 2 rows. The increment here was small, the increment over here was large, and it basically laid that out here on the graph. One of the interesting things is when you first graph it out, you can get this warning line, and that's a key indicator that your part 0 is not set up right for this operation. So whenever you see that thing, you should say, okay, I need to make sure that when I actually go to do this operation, that I in fact am in the right work envelope. But that warning goes away, and then it gives you the actual operations that you can see, and you can also look at it in different directions. I'll let it, again, I get that warning, but then it'll show it to me in 3D, so now I can take a look to understand where it's going to land, how it's going to enter, how deep it's going to drill, and it moves on. And then one of the most important things when you graph it that I always check for, and that is looking at it on the horizontal and making sure relative to where I set my Z, am I at risk of going into my mill bed here? And always make sure that, usually my practice is I put the 0 at the top or at the base, and I look for items that sit below 0.
Hey Mike, what are these little blue boxes down here? It looks like some sort of fancy limit switch. Tell us about that.
Yeah, these are pretty inexpensive proximity switches. I didn't want to go with any of the typical lever switches. You make one mistake and crush them and they're gone. These looked pretty beefy. They were very inexpensive. I think I got like 10 of them for like $30. And so they're nice, and all you got to do is put any kind of piece of metal up for them. My limits are set by just simple little pieces of angle that I can adjust and position properly. Got them on each of the axes. So when it goes into home, this thing approaches it, and it trips the switch. The Acorn then knows it's homed. The repeatability is about a mil. So variations from cycle to cycle, I'm seeing routinely less than a mil in terms of repeatability, which is excellent, especially for the price. And then on the other side, software-wise, relative to home, you set the maximum travel. And so coming at it from the opposite angle, this is just a safety check, because if I did my work right and I homed it right, I should never actually encounter and trip that switch. Because I set the software limits shorter, but this is the extra final safety in case I do overrun. So basically I got all those limit switches coming into a little side box that then gets run into the Acorn in terms of their inputs here. So very simple. They just need, they're actually pretty flexible. I think they're good from 5 volts to 32 volts. They're pretty generous, wide range. And normally closed. You always want normally closed because you don't want a broken circuit to then prevent from correct operation. You want that broken circuit to then trip the Acorn and say, I got to do maintenance on it.
So when I came into your shop, you have a new addition here in the shop from the last time that I was here, Mike. Tell us what it is and why you bought this.
Well, you know how it is. If you have a mill, you have to have a lathe as well, right? So I picked this up for a pretty good deal. It's a Techno Lathe. These are known to be nice little units, not really necessarily small. A lot of schools were purchasing these because Techno did a nice job of outfitting a CNC operation with a nice safety cage. It had safety interlocks working. Really a nice unit. Unfortunately, over time, these units, which were designed originally, I think, for Windows XP, the support for them is kind of waning. So picked one of these up and scrapped the original electronics in this thing and replaced it again with another Acorn. I actually reused the VFD. I reused the Baldo motor. It's a very nice motor in this unit. And so basically pulled out the controllers and just rewired the whole cabinet around the Acorn. And then I went ahead and replaced the drives. I could have used the existing steppers. They were actually pretty good. They actually have encoders on them. But I didn't want to go through the process of having to tune the drives and doing that manually. The Technic motors are just so much nicer. Single power supply, power signal cable to them. They're self-contained servos. They tune really well. And I have a video that we can show a link to where I show how initially these untuned Technic drives, you can see the jitter going on this table. This ball screw isn't perfectly round. There's a little bit of variation in it. But after the auto-tuning process, I show in the video that this motion is as smooth as can be. And it turned out really well. These nice motors. And of course, I replaced it with a nice quick change tool post set. Here's a part that it's in process right now. Gets a really nice finish. I tightened up everything here, and I'm producing some really nice round table's really nice and true. So I'm happy with that. I did an initial test piece here, suspended out to the tailstock, and with just a minor amount of the tailstock tuning, I got consistency on less than a half a thousandths of variation in thickness here, in diameter, running this whole length. This is about, I'd say about 9-10 inches. So really happy with the accuracy and precision that this is offering. And the really cool thing is how with this drive and its encoder through the Acorn, it is tying the Z axis to that spindle. So motion can be coordinated. You can use the G99 feature. And so basically you can set an increment per rev, and that will guarantee you to get a really nice finish when you do this operation.
Can you give us a little demo of that?
Yeah, so you can go to the MDI menu here, and the key is the G99 mode, and I'll just do a code where G99, that locks the spindle to the Z travel. G1 is your basic linear motion, and I'll just go from, I'm currently at like -2, we'll go to -8 there. So I'll put that in play. It's running, but because the spindle isn't running, it's not going to move. But as soon as I start moving the spindle, the Z-axis moves along with it. And it'll continue to move along with it. And I can literally go in either direction. I can do some tight movement. It is 100% locked to that Z-axis until I get to 8. And that is the finish of the command because it actually reached where it needed to get to.
Hey, Mike, thanks a lot for taking the time to give us the shop tour with your CNC machines here. You got anything in the works? So what's on the horizon? You got any more projects on the way?
Yep. So as I mentioned, working with the high school robotics program, they want to get into some CNC, so we're actually in the process of ordering a router I asked for the bare bones aspect to it, just mechanicals, because the company wasn't offering at this point an Acorn version of it. I really like it. I wanted the kids to have the same interface for lathe and mill, and also really important. You know, these kids graduate through high school pretty fast, 4 years and they're out. So there needs to be the inheritance of the knowledge base. So I'm actually having them build out the electronics cabinets around the Acorn, and that will force them to have to do the schematics, understand it themselves, and then they will be in a position to pass it on from year to year as the kids graduate out. So they're having fun already. As I mentioned, they're already doing some bench testing with an Acorn, getting prepared. We got the motors on order, and once the unit comes in, we'll be able to actually outfit the electronics cabinet to the router.
Man, thanks a lot, Mike. We're looking forward to that. Talk to you soon.
Thank you.